All right, so we're on worksheet 11, talking about graphing quadratics and changing forms between different versions of that. We did a warm-up and I forgot to record it, so if you're watching the video, you're in luck. You don't have to watch the warm-up. All right, when we talk about quadratics, a quadratic is anything that can be written in this form, just like we talked with quadratic formula, okay? All things that are quadratic, meaning they can be written in that form, would graph as a what? What is this called, guys? Good job. Parabola. A parabola. Okay. All parabolas are transformed, stretched, or shifted, or flipped versions of y equals x squared. So when you put in an x and a y, you're always squaring it. 0 squared is 0, 1 squared is 1, but negative 1 squared is also 1, 2 squared is 4, negative 2 squared is still positive 4, 3 would be 9. Everybody good? Okay. So when you put them into this equation, you will always get this shape. Now, when we start stretching and flipping and shifting, that shape can look very different. Later in the year, I hope we have time to do conics, in which case it can actually be sideways. Flip the x and the y. All right, but not now. So the vertex is going to be called H and K. This is general form. This is the vertex finder recipe. This is the vertex form. All of this is either in your notes or we're going to go over it now. This is called standard or polynomial form. I've also seen it called general form. Ax squared plus bx plus c. Okay? It's great if you got to do quadratic formula. It's not as helpful if you want to find the vertex, etc. Okay? The x-intercepts, if we wanted to find the x-intercepts on this one, you would set the y equal to 0. If we were doing this without a calculator, you could factor out a 2, and you'd have x squared minus 2x minus 3. Does that factor, guys? Factors of 3 would be negative 3 and plus 1, I think, okay? So to find the x-intercepts, you set y equal to 0 and factor, or you use your calculator, or you use quadratic formula, but you have to put the 0 in for the y to find x-intercepts. So I have 3 and negative 1, so that would be 3, 0, and negative 1, 0. 1, 2, 3, and negative 1. These graphs are not going to be very accurate, I'm telling you right now. Okay, the y-intercept, do you remember that part, guys? You put what is 0? Put in the x equals 0. So can you do that? 2 times 0 squared minus 4 times 0 minus 6 is what? Anybody awake? Negative 6. Yeah, the only thing that's left when you multiply this by 0 and this by 0 would be a negative 6. So you put in a 0 and got out a negative 6. Somewhere down here. So this is what our parabola looks like. I actually should have found the vertex first. Oh my goodness, we need the Hofbauer big dot theorem over here really bad. Okay. The vertex of this parabola, what would the vertex be called on your, if you were going to find it on your calculator? Anybody remember? Is that a max or a min? Yeah, it's at the bottom of our parabola, so this would be the min if we were using the calculator. But this form, when you have this general or standard form, this is what you need to use to find a vertex by hand. It says use x equals negative b over 2a, or the opposite of b over 2a. It is, I will call this the vertex finder recipe. it will find the axis of symmetry, and then if you plug it back in, it'll find the whole vertex. So for this question, x equals, what is the opposite of b over 2a? Well, our b was -4. Everybody good that it was negative? So when we change it, it'll become a +4 over 2a, which is 2 times 2. So what does that all simplify to? Yeah, 4 divided by 4 is 1. So the axis of symmetry is at x equals 1. Is everybody good what an axis of symmetry is? Okay, it's a line that goes down the middle, has to have an equation of x equals. And that means 1 is the x value of the vertex. Then you plug it back in. 2 times 1 squared minus 4 times 1 minus 6 will give you 2 minus 4 minus 6, which is -8. Anybody? Did I do that right? I think so. So the vertex is at 1, -8 down there on my crummy graph. Okay, so it says use the vertex finder recipe to find the axis of symmetry, then plug the x back in to find the y value of the vertex. If you had to switch this to vertex form, and we're going to practice this, but this is vertex form, which is the next one on your notes, I think, but the a right here stays the same as whatever it was when we started this problem, which was a 2, okay? The a was a 2, and we just found h and k by finding the vertex, so it would be x minus 1 squared minus 8. We're going to practice that, but that's how you switch to vertex form, is you find the vertex and you keep the a. Or you do completing the square in a really messy, complicated way that I'm not going to do. All right, spent way too much time on that one. Let's move on. This is vertex form, which seems like it should be the nicest one of all. It tells us h and k right here, but be careful, it is the opposite of h. So h is what? H is -5, k is +4. So our vertex is at -5, 4. And I'm just going to sketch because this is a mess. -5, 4 would be somewhere over here. Does anybody know what that -3 out front does? You remember that? Yes, the negative means it's going to open down. And the 3 actually means it's going down 3 times as fast. So it's actually going to be very narrow. It does not have nice x-intercepts. They are called the zeros on your calculator if you want to find them as a decimal. I can also show you real quick. We learned it this way last week. If we wanted them exact, we would subtract the 4 over here. You don't have to write this down if I know there's not much room. Then you would divide both sides by -3. Anybody know what we'd do next? Square root. And we'd have the square root of this would be 2. We'd have a disgusting square root of 3 in the denominator. We'd still have to subtract a 5 over there. They're going to be really ugly, okay? Really ugly. So let's use the calculator. This is a real important issue. You can't have a plot up here turned on if you're going to graph most of the time. So if you arrow up and hit enter, it will turn that plot off. And then you can clear out anything you have here. Okay, somebody's going to bring me their calculator in a minute, and they're going to have one of these plots darkened in. Does everybody know what I'm talking about? Plot 1, plot 2, plot 3 across the top cannot have a box. If it looks like this, then that plot is turned on and you need to go up and turn it off. All right, we're going to put in the equation for this question, which was -3 parenthesis x plus 5 squared plus 4. All right, let's just start with a zoom 6. Can you do a zoom 6 or a standard window? Who needs help? You should be using this button for the X. Did you do zoom 6? Is it good now? Anybody else? Everybody got it? Okay. If we are trying to find those x-intercepts right here, you go to second trace. What are they called? The zeros, which is choice 2. Now at the bottom of your calculator, it says left bound. I detest scrolling around on my calculator. So I usually tell it numbers. This is 1, 2, 3, 4, 5, 6, 7 negative. So it is somewhere between -7 and -5. So I usually type it's on the left close to -7, on the right close to -5. I hit enter and it finds it. You are welcome to scroll around. So what you do is you go to 0, and yours was way down below at -71, so you have to scroll until you're to the left of it. Enter, till you're to the right of it, and then you can scroll back here and hit guess or just hit guess. You need a number to the left and to the right in that order if you're going to type the numbers. How we doing? Who's totally lost? Antoine, you okay? Are you moving? Okay. I was sick. Is he frozen? Okay. I'm going to try second calc again to find the other one. What numbers could I put in over here? What is to the left of that? I'm looking for this one now so I could scroll over here, but you were probably taught to do it this way. You scrolled close, right? And then you went left a couple times and you hit enter. And then you crossed and went right a couple times and hit enter. Guess, maybe you went back close by it and then hit enter. All right. Is anybody getting crazy numbers back here instead of 0? Sometimes you get like something with an E, okay? That's a calculator error. It's giving you a scientific notation version of 0. Is everybody okay? So what did we have? I got -3 point, what on that one? -3.8 or was it 3.9? And the other one was, thank you. All right, this was too disgusting. I shouldn't have even shown you this because it didn't help at all. All right, we have a vertex up here and we have a couple x-intercepts and we know it's opening down. Please don't make them look like V's, guys. They are curves, okay? Should not look like a V on your paper. The y-intercept, remember, you get when you put in x equals 0. So we could do that by hand, or since we graphed it anyway, you can just go trace up at the top here, trace, and then type a 0, enter, and it's clear down at -71. If I had done that by hand, when I put in a 0 plus 5, I would square it first and get 25 times negative 3 is negative 75, plus 4 is negative 71. Yep, that is not going to fit on my graph anytime soon. All right, there's one more form that I promise I'm not going to quiz you on much because it's not a very useful form in my opinion. Oh, this is just about transformations. Anything inside of here shifts your graph left or right, the opposite of what it seems. Anything back here shifts your graph up or down. The A indicates the stretch or whether it opens up or down. If A is negative, it opens down. We will talk more about those when we get into parent functions and transformations. This form is called x-intercept or factored form. It's great for finding the intercepts. If I set that equal to 0, what are the two places that will make this 0? If x minus 5 equals 0, I get x equals 5. If x plus 3 equals 0, I get x equals negative 3. Can 1/2 out front here ever equal 0? No, so that's just a stretch or a flip or something. It doesn't affect the x-intercepts. So they were at 5, 0 and negative 3, 0. Very easy to find because it was in factored form. Okay, the y-intercept, how do we find the y-intercept again? X equals 0, so we would have 1/2 times 0 minus 5 times 0 plus 3. Half of negative 15 is negative 7.5. So down here somewhere at negative 7.5 would be the y-intercept. Now, the vertex or axis of symmetry from this form is not so fun. You could find it on your calculator. It's actually halfway in between. It's always halfway in between the x-intercepts, okay? If I average those x-intercepts, I get 2 over 2 is 1. So x equals 1 is the axis of symmetry. And then how could I find the rest of the vertex? Same way I did on the first kind. Anybody remember? Put that 1 back in. Half of 1 minus 5 times 1 plus 3. I would have half of negative 4 times 4. This would be negative 16. Half that would be negative 8. How about we do it on the calculator? What do you think? We talk through graphing that bad boy on the calculator. If you go back to your y equals and clear this out, usually you want a calculator in parentheses. It actually wouldn't matter here. And then it was x, I already forgot, minus 5 and plus 3. Everybody knows where the parenthesis buttons are and everything. Okay. If we do a zoom 6 again, okay, we found these were at negative 3 and positive 5. That looks really good. How do you find the y-intercept again? Trace 0. Okay, negative 7.5. Now, does anybody know how we find that vertex down there? If you go to second trace, is it a maximum or a minimum on this graph? It's a minimum because it's at the bottom, okay? So we would pick choice 3, and then again you would say, I'm a little bit to the left of what I want to find. I'm a little bit to the right of what I want to find now. Now, this is calculator error, guys. Your calculator is estimating. What it does is it cuts it into smaller and smaller pieces until it finds as low as it can go for the y. So that is really 1 negative 8, okay? This is just calculator error. So you need to recognize that, and you would just get 1 negative 8. How we doing? Already feeling overwhelmed? Okay, was there anything you needed me to write down in terms of calculator buttons? All right. In each version, A will tell whether the parabola will open up or down. Will open up if A is positive, down if A is negative. And that's going to be called a reflection over the x-axis when we talk about transformations. It also, the A indicates whether the vertical stretch is narrow or makes it wide, okay? Opening direction also indicates whether the vertex is a max or a min. And you might just write yourself a little picture. When it opens down, it has a max. When it opens up, it has a min at the vertex. All right, we're almost done, then we're going to practice. Number 2 says more graphing, practice to follow, first change forms. Change this to x-intercept form. X-intercept form is also called what? Can you look at the notes right there? What is it? X-intercept form is also called factored form. So if we just factored this, it would factor x minus 5 and x minus 1. Okay, that's it. All right, the next one though, part B to that question, says change this to vertex form. This one you could do by completing the square, or you can just find the vertex, guys. I'm just going to find the vertex. Remember the vertex finder recipe? X equals the opposite of B over 2A. What is the opposite of B here? Positive 4 over 2 times 1. What does that become? 4 divided by 2 is 2. And then you plug it back in to find the y value. So 2 squared minus 4 times 2 plus 1 is negative 3, I believe. Or you could graph it on your calculator. Okay, once you have the vertex, how are you going to change this into vertex form? Well, vertex form is a x minus h squared plus k. What is a? A on this was 1, so it's going to stay 1. What is h? H and k are from the vertex, so it's going to be x minus 2 squared, and k was negative 3. I'm going to do the same thing on this. Completing this square is a nightmare when you have a number out here. If we were to start vertex form, we already know that A is 2. So we're going to have a 2 and then an x minus h squared plus k. We just need to find h and k. How did I find h and k, guys? Yeah, x equals negative b over 2a. B is negative 12, so the opposite of negative 12 would be 12 over 2a, 2 times 2. So 12 divided by 4 is 3. So x equals 3 is the axis of symmetry, so this is the h value. And then to find k, we plug it back in. Y equals 2 times 3 squared minus 12 times 3 plus 7. 9 times 2 is 18, minus 36 is negative 18, plus 7 is negative 11. 2x squared minus 12x plus 7. 2x squared minus 12x, I already forgot what I read, plus 7. Okay, if we had graphed it, it doesn't fit in this window very well. Okay, we're trying to find the vertex. How do we look at a better window? Do not use zoom fit. It is not your friend. Anybody know how we look further down? If you go to the window, what do we need more of? I need to see down on the y values past negative 10. If I change that to like a negative 20, then I can see the vertex a little bit better. It's second trace and it is a minimum. I'm just saying you could have done this instead of using the vertex finder recipe to find that vertex. But once you know that vertex, now again, what is this saying, guys? What is this number right here? 3, okay? It's 3, negative 11. Once you know the vertex is at 3, negative 11, you can just plug it in here and make sure you keep the A. All right. We are going to practice. Do you want to do 3 or 4 together? Anybody care? If we go through 3, you could plug this in your calculator. I'm going to do it without. I'm going to find the vertex by x equals opposite of b over 2a. So I'd have positive 6 over 2 times negative 1, which would be 6 over negative 2 or negative 3. That means x equals negative 3 is the axis of symmetry. And the vertex is somewhere on that line. So then if I plug that, so this is the h value of the vertex. If I plug that back in to the equation carefully, there was a negative 1 and then an x squared minus 6 times negative 1 minus 8. I can use my calculator, but I think I get negative 11. So the vertex, no, I don't. It's not what I have on my paper. Oh, that's because I'm not putting in a 1. Look, guys, I put in a 3 here and a 1 here. This was supposed to be a 3. That's why I'm not getting the right answer. So sorry. Okay, so this becomes 9 or negative 9. This becomes plus 18 minus 8 is 1. So that's the k value of the vertex when we plugged it back in. So our vertex is at negative 3, 1. Can anybody tell which way this is opening? Because A is negative 1, it's opening down. All right, you can use your calculator to find some more ordered pairs by looking at the table. I don't want to confuse anybody, but do you remember when we started this lesson today, we said 1 squared was 1, 2 squared was 4, okay? If you find the vertex, it literally will go over 1, down 1, out 2, down 4, unless you have a stretch. Every parabola is doing the same thing. Okay. But again, you could certainly have used your calculator. Can anybody read me that equation real fast? It was negative x squared, then what? Minus 6x minus 8. Okay. You can graph it, but you can also then, if you go to second graph, you can use the table to find ordered pairs. Everybody know what I'm talking about? Does this look familiar? There's some nice ordered pairs I could plot. Okay. Let's try, you want to do 5 or 6? Oh. Where were the x-intercepts on this one, guys? You can actually see them really nice on the calculator because it's where the y equals 0, so they were at -4 and -2. How would you figure out the y-intercept? Would go back to your table and put in a 0 for x. Right here it says it's down at -8. So this would actually, oh, I just lost my, there we go. Would cross down here at -8. How much time do we have left? Okay. Let's try number 5. All right, can you tell me the vertex from the form? This is my favorite form when I have to graph. It's x minus h squared plus k. So what is the opposite right here? -4, and the k back here is -6. Does everybody get that? And pick the vertex out, okay? And the a is a positive 1/2. Okay, so the vertex is left 4, down 6. And if the a is positive 1/2, it is opening up. And does anybody remember? A 1/2 actually makes it go up half as fast, so it's going to be wide. Okay, it's going to be wider. Now, the Hofbauer trick is it would normally go over 1, up 1, over 2, and then up how many? 4, because you're squaring it, but we have to multiply those by half. So it's over 1, up 1/2 in each direction, and we can look at the calculator. Over 2, you square that and you get 4, but there's a half out there, so it's going to only go up 2. So that's the shape, but again, you could have put it in here very carefully. It was a 1/2. You could put that in parentheses, but it isn't going to matter. X, somebody read it to me. What is it? Plus 4 squared. And then a, thank you. And then if you go to the table, here are some nice ordered pairs, okay? By the way, are the zeros anywhere on that list? Does the y ever equal 0? They're not nice, okay? So, but there's the shape. The axis of symmetry, just to practice some of this, axis of symmetry is x equals -4. If you wanted to find, should we practice one more time with the calculator to find the zeros? It's somewhere between, you go 0, and then you would trace over here. If I want to find this one, I go a little bit to the left of it. and I hit enter, and a little bit to the right of it, and I hit enter. I didn't go very far, but it's about negative 7.5. Okay, my method is you just type in a number. There is a 0 somewhere between -1 and 0, so I type in -1, enter 0, and -0.5. All right, so the practice on this are to do these. Please read the directions. It says you need to identify the vertex and axis of symmetry. Also identify the X and Y intercepts, even if they don't fit on the graph, okay? So you have one standard form, one vertex form, you're gonna wanna use your calculator for these. And then there's a couple that you have to change the form of. You know what, guys? You can cross off 11. Merry Christmas. Just do those 5 tonight.